Hello everyone, and welcome to the China Story. How are you feeling today? I'm happy to bring a topic to you. How advanced is China's carbon-based chip? If you find this channel interesting, you can click a subscribe and turn on the little bell, so you can be the first to know the latest information. In the previous few videos, I talked about a video of China's carbon-based chips leading the world in the next few years, and many of you asked questions about why China's carbon-based chips are developing so rapidly. So today China is going to see how advanced China's carbon-based chips are. Some time ago about the Hua chip was limited to the matter of the furor. After being restricted by the U.S. state, many companies using U.S. equipment, software and technology will not be able to provide parts to Hua. Some chip foundry companies cannot continue to OEM Hua's chips. This thing makes China once again aware of the importance of independent and autonomous domestic chips. But although China has invested a lot of energy in chip research and development over the past years, but because there has never been a breakthrough in some core technologies, so China's chip research and development is still facing a lot of difficulties. Although China has been fully localized in some low-end chips, but for high-end chips, especially high-end chips above 7 nanometers, still completely dependent on imports. Even if companies like Hua have the ability to design a 7 nanometer or even 5 nanometer chip, but want to transform this design into a real visible chip, but also entrusted to TSMC for production. Now Hua is restricted by the United States. The future of the 7 nanometer chip faces a lot of uncertainty. Once TSMC 120 days after the buffer period will mean that from late September, they will not be able to continue to OEM Hua's chips, which is a very big impact on Hua. If the United States did not relax the restrictions on Hua, the next few years Hua are likely to be greatly affected. But the sky is the limit. Although China has a big gap with the top international level in the silicon-based chips, and even everywhere in the high-end chips, but by China's independent research and development of carbon-based chips, has recently made a new breakthrough, the future even without EUV lithography. China may also be able to produce some high-performance chips. May 26, 2020, a team of carbon-based nanotube chip developers, consisting of academicians Peng Lianmao and Professor Zhang Jiang of the Chinese Academy of Sciences, has achieved significant research results in the field of new carbon-based semiconductors. The paper, High-Density Semiconductor Carbon Nanotube Parallel Arrays for High-Performance Electronics, was published in Science on May 22, 2020. Lijun Liu, a 2015 PhD student in the Department of Electronics, and Jie Han, an engineer at Beijing Yuanxin Institute of Carbon-Based Integrated Circuits, are the co-first authors, and Jiang Zhang and Lian Mupeng are the co-corresponding authors. The group used multiple polymer dispersion and purification techniques to obtain ultra-high purity carbon tube solutions, and combined with the dimensionally constrained self-alignment method to prepare carbon tube arrays with a density of 120 μUs, a semiconductor purity of 99.9999%, and a diameter distribution of 1.45 plus or minus 0.23 nUs on a 4-inch substrate, thus meeting the requirements of ultra-large-scale carbon tube integrated circuits. This means that after over 20 years of R&D time, China has not only broken through the bottleneck of carbon-based semiconductor manufacturing equipment, but also achieved the global leadership in carbon-based nanotube transistor chip manufacturing technology. Compared with traditional silicon-based chips, carbon-based chips have lower power consumption and cost, and stronger performance. According to Prof. Peng Lianmao, carbon-based chips with the same grid length consume at least 3 times less power than silicon-based semiconductors, and run 3 times faster. And chips made of carbon tubes are expected to be used in cell phones and weapons for base stations. So how powerful is this carbon-based chip? In January 2017, Peng Lianmao led a team to develop a high-performance 5 in US nanometer, 8-length carbon nanotube CUSOS device, which is the world's smallest high-performance transistor to date, with comprehensive performance 10 times ahead of the best current silicon-based transistors, approaching the theoretical limit. Its operating speed is 3 times faster than Intel's state-of-the-art 1.4 in US commercial silicon transistors, but energy consumption is only 1/4 of that of silicon transistors, and the related results were published in Science. This means that if the future carbon-based chip tube can be industrialized, will allow China to get rid of the dependence on Western silicon-based chips. According to the carbon-based machine, chip performance is 3 times that of silicon-based chips. To calculate, to produce a 5 nanometers chip, only need to have 14 nanometers of the ZR. In various fields have mastered a certain core technology, and the gap between certain developed countries is getting smaller and smaller. But it should be noted that there is still a key technical equipment in China urgently need to overcome about the development of the domestic chip business, that is, photolithography. For photolithography, I believe we are not unfamiliar. It is an essential equipment in the chip manufacturing process. Without photolithography cannot produce any chips, which is the general knowledge of the entire semiconductor industry. Before, most people have not heard of photolithography, but with the impact of the Hua chip incident, let China realize the importance of photolithography. Huawei's chip is constrained because it does not have the manufacturing capacity and needs to be supplied by a foundry containing US technology. And China is also in a relatively weak position in the field of chip manufacturing, although it can independently produce some low-end chips, but for the 7 in US, 5 in US, and other advanced processes of the chip will be powerless. Because of this, after the loss of foundry partners, Huawei is facing a shortage of chips, and amplifies the shortcomings of domestic technology. In fact, in the design and packaging of chips, China's strength is very good, not at all lose to foreign countries. But what makes people helpless is that the lack of photolithography support, resulting in China has never been able to completely overcome the chip manufacturing. In order to further promote the development of domestic chips, and help Huawei out of the dilemma, China made a decision to fully lay out photolithography. It is understood that China's highest level of science and technology institutions in the Chinese Academy of Sciences has been moving in this direction. The future will focus on the strength of the entire institution to conquer lithography and other technologies that are easy to be foreign. It can be expected that, with the support of CAS, the domestic lithography machine can certainly continue to make progress. This problem will soon be solved. Not only that, recently the Chinese Academy of Sciences officially announced that 2 technologies have made a breakthrough. The difficulty is comparable to lithography. In other words, in addition to lithography, the Chinese Academy of Sciences has conquered 2 extremely difficult technologies. CAS2 technology breakthroughs. First technology is a new OLED display material. The Chinese Academy of Sciences, led by academician Li Yadong mass production project, has started laying the foundation stone. Although the domestic screen manufacturers OLED materials also have some research, but compared with Samsung, the gap still exists. In order to make up for this gap, the Chinese Academy of Sciences has stepped in. Li Yadong academician led by a new OLED materials research team is working hard on the research. Perhaps it will not be long before the domestic OLED screen can be achieved instead of Samsung. A LED screen for cell phones, computers and other electronic products is indispensable, so the research and development work of the Chinese Academy of Sciences is necessary. As long as the domestic screen can be recognized by the people, it can occupy a larger market, so as to obtain a better space for development. The second technology of CAS breakthrough about chip provides a new development direction for domestic semiconductor companies. It is reported that in the Shanghai Institute of Microsystems of CAS, 8-inch graphene wafers made their debut and are ready for mass production. This means that China is leading the world in research on carbon-based chips, and if the wafers can be cut perfectly, then a real carbon-based chip will be born. All along, the chips have been using silicon-based semiconductor materials, and although the performance is still good in all aspects, they cannot continue to progress as long as they reach their limits. So many countries around the world began to target on the carbon-based chip. Its performance and stability is stronger. Once the breakthrough will definitely cause changes in the semiconductor industry. Now it seems that China has achieved a leading position in the field of carbon-based chips. The debut of 8-inch graphene wafers represent the domestic chip may be able to achieve overtaking. But this is not enough. To succeed in the rise of domestic chips, must continue to move forward. Carbon-based chips and silicon-based chips are to seize. The two good news announced by the Chinese Academy of Sciences for domestic technology has important significance, but also to promote the development of many Chinese enterprises. I believe that in the future, China will be able to continuously break through various core technologies and achieve the goal of a strong country in science and technology. Let China wait and see. Thank you for watching this video. If you find our videos very interesting, please read and subscribe to our channel. What you do is what makes us happiest. If you have any ideas, you can leave them in the comment section, and we will see you next time.